Dear students, today I am going to teach you Coulomb's law in electrostatics. Coulomb's law, it states the force of interaction between any two charges, any 2-point charges, is directly proportional to product of the charges and inversely proportional to square of the distance between the two charges. This means, suppose we have two charges Q1 at A and Q2. These are the two charges Q1 and Q2 at A and B, separated by distance r. These are the 2-point charges Q1 and Q2, separated by distance r. These two charges interact. Interact means these can either attract or repel. If the two charges are like charges, then they will repel each other. As you know, if these are the two charges which are opposite to each other, that means they are unlike charges. At the time they attract each other. The force of interaction F, force of interaction F is proportional to Q1, Q2, the product of the two charges, product of the two charges, and inversely proportional to square of the distance between the two charges. If this is first, this is second, at that time we say we combining 1 and 2, फर्स्ट और सेकंड को हम कंबाइन कर लेंगे, we get F proportional to Q1 Q2 upon R square. This Coulomb's law. We change this proportional to inequality. At the time we multiply by constant. F is equal to constant times Q1 Q2 upon R square. This constant is denoted by K. That is, we write F is equal to K times Q1 Q2 upon R square, where K is constant of proportionality. And this K has a value. We can write the value of K as the value of K is equal to 1 upon 4 pi epsilon naught, which is equal to, when we substitute the value of 4 pi epsilon naught, it has a value 9 into 10 power 9. From this we can calculate its units also. That is, Newton meter square per Coulomb square is its unit. At the same time, we know this epsilon naught has a value equal to 8.85 into 10 power minus 12. We can again calculate it from this relation. It is Coulomb square per meter square per Newton. This is the unit for epsilon naught. Where epsilon naught, this is known as permittivity. Permittivity of free space. Permittivity means to permit, to allow the lines of force to pass through the particular medium. Here we take for granted these two charges Q1 and Q2 lie in free space. Free space means either vacuum or in air. So F has value equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. This is Coulomb's law. Now this Coulomb's law has two parts. It has two parts, means when the two charges are like charges, at the time there is a repulsive force. If the two charges are unlike charges, then there is the attractive force between these two charges. So we will discuss now this Coulomb's law in vectorial form. Coulomb's law in vectorial form. Case first. The first case is when the two charges, 2-point charges, are like charges. Suppose, or let we say Q1 and Q2 be two like charges at A and B, separated by a distance R. Therefore, we write Q1 here, Q2 here at A and B, separated by distance R. Now you know here these two charges are like charges. This means Q1 repels Q2 with a force F21. We write it as F21. And Q2 repels Q1 along this way with a force F12. Here, when Q1 repels Q2 with a force F21 is equal to F12 is equal to 1 by 4 pi epsilon naught Q1 Q2 upon R square into, the direction is from here to here, R12 cap. R12 cap is a unit vector which shows the direction of the force from Q1 to Q2. Here, this is according to Coulomb's law. Coulomb's law. Similarly, when Q2 repels Q1, then this is called as first, when Q2 repels Q1 with a force given by F12 is equal to 1 by 4 pi epsilon naught Q1 Q2 upon R square. Here the direction is shown by R21 cap. It is a unit vector, R21 cap. Call it second. This is again by Coulomb's law. But here from the figure we observe, Here from the figure we observe that R12 vector is equal to minus times R21 vector. These are two unit vectors. One is from towards right and second is towards left. That means this negative shows they are opposite to each other. This you can call third. Therefore, equation second can be written as second equation को हम ऐसे लिखेंगे as F12 is equal to 1/4 pi epsilon naught Q1 Q2 upon R square into, instead of R21 I will write here minus R12 cap. This is fourth. Now you compare equation first and fourth. From equations first and fourth, we get F12 is equal to minus times F21. So these two forces are equal. That means F12 and F21 are equal in magnitude, but opposite in direction. Hence, these are Newtonian forces. That means the Newton's law holds good here. Now, case second. The case second is here when the two charges are unlike charges, Q1 and Q2 at A and B. These two unlike charges attract each other. Q1 attracts Q2 and Q2 attracts Q1. From this, the force is F21 and F12. That means Q1 on Q2 is F21, Q2 force on Q1 is F12. We can write that F12 is equal to, according to Coulomb's law, 1/4 pi epsilon naught Q1 Q2 upon R square. Again you will write as R21 cap. And F21, the force, is equal to, again 1/4 pi epsilon naught Q1 Q2 upon R square R12 cap. Here again you say R12 is equal to minus times R21 cap. This equation we say here, it is fifth, this is sixth, this is seventh. From equation 7th and 6th, we have F21 can be written equal to 1/4 pi epsilon naught Q1 Q2 upon R square, then minus times R21 cap. This we call as 8th. When we compare equation 5th and 8th, comparing equations 5th and 8th, we have again F12 is equal to minus times F21. So these two forces are again equal in magnitude but opposite in direction. So either the forces are the two forces between the two charges, if the two charges are like charges or unlike charges, they hold here, that is F12 and F is equal to minus times F21. That means these are the Newtonian forces. Then this is the whole for today. That we meet in next video.